All right, so in lesson 6, we're going to continue on with limits. We're just going to do some kind of basic practice with looking at a graph and figuring out how the limit reacts in that graph and just kind of looking at a very visual representation of limits. If you guys can remember from that last lesson that we just did, it was really important. We came up with a limit exists. So the limit exists if it's approaching from the left and the right the same point. If it approaches a different point or two different areas or something doesn't exist or something's happening at that point, then the limit may or may not exist. Okay, so we're going to look at some examples of where limits are kind of doing some funny things. So it's basically saying for A, what is the limit as x is approaching -1 of our function? So the first thing we want to do is find out where is -1 and take a look, because remember the limit is always talking about kind of our y value. Now in this case, again, we want to go back to the basics and say, is it approaching the same number from the left side and the right side? Well, you can see nothing too crazy is happening with that point. It's just y is equal to 3. So we don't need to overthink this one. Nothing crazy is happening. So we know 3 is going to be our limit. What about 9? Let's take a look at that one. So when x is approaching 9, again, first thing we want to do is figure out where is 9. We want to follow it down all the way to our point to see, is anything crazy going on there? Well, from the left side, it's approaching that point. From the right side, it's approaching that point. So really nothing crazy is happening. And we know it's around, we could say about -4.5. So that limit is going to be about -4.5. Now we'll get into the good stuff, a little bit more interesting, where things are happening a little bit more. Now the first question for C is saying where f of -5. So all that's telling us is, what is y when x is equal to -5? Well, when x is equal to -5, what is y? Well, hopefully you're saying y doesn't exist. It's an open circle. It means it doesn't exist. So again, we don't have to overthink that. It just means it does not exist. Another symbol that we can use for that is just a 0 with a line through it. Now let's switch it up, and we're still going to talk about that same point, but now instead of just looking for, okay, what is y, we're going to say, what is the limit as x is approaching -5? So that's a little bit different. Now remember the basics. The limit exists if it is approaching the same point, whether or not that point exists, if it approaches the same point from the left and the right the same. So let's take a look. From the left, it looks like it's approaching 4. And from the right, it also looks like it's approaching 4. Because it's approaching that same point, even though that point doesn't exist, our limit does exist. And that is going to be the number 4. All right. So again, if you have any questions with this, just go to the help desk. But remember, if it approaches the same number, you're good to go. Let's take a look at the last little section here, f of 2. So remember, f of 2, that means x is basically equal to 2, right? So what is y? We're not talking limits just yet. Well, if I said, okay, what is y when x is equal to 2? Hopefully you're saying, okay, well, it must be 2 because that point does actually exist. This one doesn't, but that one does. So our answer would be 2. Now let's talk about our limit. I'm just going to erase this part here. So as x is approaching 2 from the left-hand side, my graph is following that line there, because remember I'm looking for when x is equal to 2. But from the right-hand side, my graph is actually approaching -2. So go back to what we said originally. The limit exists if it approaches the same number. Is this approaching the same number? Absolutely not. So we need to say our limit at that point does not exist. If I look at something else that's kind of cool about graphing, and I know this says finding limits algebraically, but this is kind of more still talking about graphing here. If I say the limit of a constant, so remember if my function in this case is equal to -2, what is the difference between this function and all the other functions that we've been using? Obviously, it doesn't have a variable in it. So if it doesn't have a variable, that means that it is a constant. And hopefully you guys remember that the graph of a constant is always just going to be a straight line. So basically we're saying that my graph is equal to -2. If I literally draw a picture of that, guys, it's going to look something like this, right? That means every single point is just -2. Well, the cool thing about a limit of a constant is that 3, 4, 5, if x is approaching 5, remember, go back to the basics. As long as it approaches the same number from the left and the right, your limit exists. And what is the limit approaching? Well, obviously, -2. Okay, it's not moving. So my limit is automatically going to be the same as what that constant is. And this actually is cool because it works for every single constant. So if I give you another one, let's say the limit as x is approaching 2 of 6, let's say for instance. What is that equal to? Well, 1, 2, 3, 4, 5, 6. Got our line here. That's what our graph would look like. When x is approaching 2, so I've got that point here. And if I'm approaching from the left, it's 6. If I'm approaching from the right, it's still 6. So therefore, my limit is still just going to be whatever that function is, whatever that constant is. So in conclusion, we could do this a million times and we'd still get the same result. The limit as x approaches any number of a constant is always just going to be that constant. Now, guys, you'll see that there's a little bit of practice here, page 18. Make sure that you're doing that, 1 and 2, and don't forget all the solutions are already on the virtual classroom for you to check your work.